Hi, Mr. Ray here again. Well, this is the fourth video in our series on gyro navigation. And on the screen I have the program we ended with last time. This program would allow you to start the robot and turn to some direct heading that you had specified in the call to the my block, and proceed for the number of wheel rotations that you specified at the speed you specified. Today we're going to add one more parameter, and we're also going to modify this so that it will work going in forward or reverse. Now there will be some rules on how this works, so I'm going to put the rules up briefly here and as to how this will work, and then we'll modify it, and then I'll go over the rules again just to be sure. So here are the rules. The speed will control both speed and direction. So when we add reverse, the way you will tell it to go in reverse is to give it a negative speed. Rotations, for the number of wheel rotations, will always be specified as a positive number. And if the robot is driving the wheels in reverse, the my block will automatically correct for that. Heading is measured relative to the initial heading of the robot, as long as you don't reset it. And there will be a new parameter called limit, and that will determine the sharpest turn rate for the robot. Perhaps that shouldn't be called a rate. It will determine what kind of turn at the maximum you can do. So a value of 50 for the limit will limit the turn to a pivot turn. 100 will allow a full point turn. If that number is less than 50, then it will be a sweeping turn. You'll have to experiment with that to see what you want to do. All right, so now let's get back to the program. Okay, so the first change we're going to make is we want this thing to work if we go in the reverse direction. The first thing I'm going to do is to kind of simplify things. Later I'm going to take this value and I'm going to put it in a new variable. So I'm going to create the variable, make a new variable, and I'm going to call it HDG_ERR. Stands for heading error. And then I need to set its value here. Down in the repeat, I'm going to set heading error, if I can find it right there, to this value. And then I'll grab heading error and I'll put that in there for the moment. So now that really hasn't done much. It just moved this calculation outside of this start moving. So now the difference between going forward and reverse is, if I'm going in reverse, I will have to use the negative of heading error. So I need to know whether I'm going forward or backward. According to the rules I gave you, the speed up here will be specified as positive if I want to go forward and negative if I want to go backwards. Instead of this simple one start move, I need to put an if in here and figure out what direction I'm going. So let's go back up to the controls and let's get an if then else. Now these things can sometimes be hard to get in here. So now I move this in and I put my start moving for going forward here. So now I need to know if I'm going forward. So what I want to say is the speed greater than 0? So let's go over and get some controls. Find a greater than. Stick that in there. And I want a 0 there and a speed. Now if the speed is greater than 0, I want to go forward, and so I use the same command I used before. If it's not greater than 0, it's either equal to 0 or less than 0. If it's equal to 0, the robot won't move. So let's repeat this. We'll put it down here. Now I need the negative of this for going in reverse. So I'm going to pull this out, and I'm going to get I'm going to use minus. I could use a multiply here. Put this in, put a 0 there, and then I'll stick the heading in there. So now I have essentially negated this. As I said, I could have multiplied this by -1 instead of subtracting from 0. As a habit from my old programming days, subtracts don't take as long to do as multiplies, so I subtracted. The next thing I want to do is I want to get rid of these. Get rid of that, because I just want one of these. Okay, before we test this, I'm going to go ahead and add the terms that will limit the turn to either be a pivot or even just a sweeping turn, if that's what I want. So what I'm going to have to do is I have to edit my block. I want to add a label. Going to call it lim. Then I'm going to add an input, which I'm also going to call lim. And I'm going to save it. Now I have a new one, a new my block. I'm going to pull it back up a little. Reduce the size, and I'll pull it up again. Okay, so now we're ready to put the limit in. So what I want to do to limit it, if we were to go back and look at these start moving. Okay, so let's pull one of these out and see what it looks like. So this is what the bare one looks like. If I modify this, this is how I tell it how much to turn. You'll notice it can go from -100 to +100. So what you need to know is if you put -100 or +100 and you do a turn that is fairly large, the robot turn will start as a point turn, meaning the robot turns on itself. If I were to set that at -50, then the robot in a large turn would do a pivot turn initially. If I make it less than 50, then it will do a sweeping turn. So now what we're going to do is we're going to use this limit value to set the maximum positive value that we can put into this hole where we have heading error. And we'll use the negative of that limit value to set the smallest value that we can put in for a negative value. Now smallest meaning if I put -50 in, I will not allow the value to be less than -50, which -100 is less than -50. Okay, so I'm going to throw this away. And we got to figure out how we're going to do that. So now to do this, we need to limit heading error based on the value we specify for limit. So let's bring in I think we need an if-else. I'm just going to bring it in for the moment. Well, I don't want it there. And under the else, I'm going to want another if. Okay, so now I need to put this in right below this instruction. So I'm going to pull this out and put this one in. And then I'm going to try and put this one in right below it. There. I have a little trouble with these things at times. They don't want to cooperate with me. I better shrink this just a little bit. Pull these back up. So now I want to check and see if my heading error is greater than lim. So I need to go over my conditionals, find the greater than, and find heading error. put the limit in here. And now I need, if the heading error is greater than lim, I want to set the heading error to the limit value. So change that to heading error. Set it equal to the limit. Now, if the heading error is less than the negative of lim, then I want to set it equal to the negative of the lim. So let's try another one of these. When the heading error is less, again, I'm going to put heading error in here. Now I want the negative of lim, so I'm going to have to go over here again and grab a subtract. Put a 0 in there. Whoops, 0. And lim in here. Now, so this is if the heading error is less than the quantity 0 minus lim. In other words, the negative of the limit. Then I will set the heading error and I need that value. All right, so what have we done here? So we've come in and we've calculated the heading error. If the heading error is greater than the value of our limit, we've set the heading error to it. So now then the heading error cannot be larger than lim. If the heading error is less than the negative of the lim, we set the heading error to the negative of the lim. So think about what that means. If I put 50 in here, then the robot will never turn sharper than a pivot turn. If I put 25 in there, the robot will only make a sweeping turn. And you'll have to figure out how much of a sweeping turn that will be. Okay, so now we're ready to test. I'm going to make the robot a lot bigger. Move this over just a little bit. Okay, so now I've got it set up so you can see the picture. I'm going to change this drive instruction so that it does a, how about a 180? We'll probably put in, say, 4 rotations, and we as well as get right on it. I'll say minus 25. So I'm telling it to go backwards and turn to 180. Put 50 in for the limit, so it should start out looking, or it should look like a pivot turn, basically. So let's see what it does. All right, so you saw that was basically a pivot turn. Well, let me get it back. Now I'll show you what happens if you were to change this limit to, say, 30. So you see that was a sweeping turn. It was a little not as sharp as I expected it to be. If I kept making the limit smaller, then that turn would get where it would, where the sweeping turn was much wider. I'll do it one more time. This time I'm going to make this limit 15. And let's see what happens. So you can see I have a much shallower sweeping turn. Going to run over something maybe. Now let's do something else. So now I'm going to change this so that it is doing a minus 180. And I'm going to put it back up to where it's more like a pivot turn. And let's see what happens. So I'm just testing now that it will turn in the opposite direction. We can keep on doing this. I guess to test this fully, you would need to test it also going forward and turning in both directions. So it should have quite a bit of testing, but I think you'll find it's all here. So I've it set up again. This time I have changed my block to say to turn to minus 180, go 4 rotations at a speed of 25, and I've set the limit at 100. And I'd better move the robot out a little further. So in this case, the robot should turn on itself in almost a point turn and then come back this way. I wanted to bring up the rules for operation using gyro navigate again. Remember that the speed controls both speed and the direction, forward and reverse. Rotations are always specified as a positive number. If you put a negative number in, the robot won't go anywhere. The heading is measured relative to the initial heading of the robot, and the limit determines how sharply the robot turns. Remember that 50 will make it do basically a pivot turn, 100 will allow it to do a point turn. So that's all there is to the rules, and let's get on with it. We have one more video to finish this. We want to be able to control the turn where it turns a little more quickly. We need to add a term that will multiply this heading error by a value, and that will let us turn, I'll say, more accurately, and it will hold a heading more accurately if that number is greater than 1. On the other hand, we will have to be careful, or the robot will become unstable after the turn, and it will, what I call the hula, it will wag back and forth. So in the next video, we will put that small change in and then demonstrate what happens with the gain. Normally, if we're going to run really fast, we have to use a lower gain than we would if we were running slowly. So we will add one more parameter called gain in the next video. So now I'll shrink down the picture so you can see the whole thing if you would like. Okay, and that will do it for this video. So if you want to see the whole series, you can go to Ray's Robotics channel, and the playlist for the series will be Lego Classroom Navigation.